All right, welcome to the quadratic formula and the discriminant. You must be pumped now. Let's take a look at our toolbox for solving quadratics. You can solve quadratics using factoring. Right? Set it equal to 0, factor it, set your factors equal to 0, find the zeros. Using square roots, whether they're real answers or imaginary answers. And we know that if they're imaginary answers, it means that probably either opens up above the x-axis or opens down below the x-axis and it doesn't cross it. Or you can complete the square. And now you can use the quadratic formula. Okay? So A, B, and C, we have to have this thing in standard form. And then identify your coefficients, A, B, and C. A can't be 0, and again, if it was, it wouldn't be a quadratic. And here's our show. The value of x, right, your zeros, are equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. You're going to find that this is very user-friendly. You just got to go slow and easy with the arithmetic. Let's try one. All right, so we got x squared plus 3x equals 2. First of all, this is in standard form, so we're going to subtract 2 from both sides. And we're going to be left with x squared plus 3x minus 2 equals 0. Okay, now we just need to identify A, B, and C. You know me, I'm big on let's get this out and identified separately. Don't just do it on the fly because you're going to make a mistake. Okay, so now we got the quadratic formula. X is equal to the opposite of B plus or minus square root b squared minus 4ac all over 2a. So let's substitute our values in. X is equal to negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 2. Right, so I'm going to put that in parentheses so I don't think it's subtraction. All over 2 times 1. All right, now let's use some arithmetic to process it. See what you could do. Press pause. You should have ended up with negative 3 plus or minus the square root of 17 all over 2, right? Because negative 4 times negative 2 is positive 8, and 9 plus 8 is 17. And I can't reduce that. And this is truly two numbers. 3 plus 7, negative 3 plus the square root of 17 is approximately like 0.56. And negative 3 minus the square root of 17 is approximately 3.56, negative 3.56. Graphically, after we have it in standard form, we can graph this thing. And here's the, 0.56, right around a half, and then 1, 2, 3, 4, and right in between that's at our other 0. So, negative 3 plus or minus square root of 17 over 2, with the coefficient of the quadratic term 1 opening up. This is what our parabola looks like. And these are our intercepts. This is the example that I think will sort of send a message home that the quadratic formula actually is really, our best bet, our best option, our best friend. Well, maybe not a best friend. I might be taking it a little over the top. All right, let's get this sucker into standard form, shall we? So subtract 12x, add 9. Subtract 12x, add 9. And what do we get? We get a 25x squared minus 30x plus 9 equals 0. All right, now we're looking at standard form. So A is 25, B is negative 30. Don't forget the signs. C is positive 9. X is equal to the opposite of B, plus or minus the square root of b squared minus 4ac. Whoops. C all over 2a. Notice I keep writing out the formula. Why? Because you're going to have to know this off the top of your head. If you have a good habit of writing the formula a lot, at least at the top of each page, you'll be in good shape. Okay, so now in practice here, that was theory. Opposite of b is going to be now positive 30 plus or minus this big square root, negative 30 squared minus 4 times 25 times 9 all over 2 times 25. All right, take a moment, process that up, see what you get. Press pause. So, after a little bit of number crunching here, you end up with the square root of 0. And there's only one answer for the square root of 0. So that means there's only going to be one 0 here, 3/5. When we go back now to this thing in standard form, this parabola right up here, right here is when we had it in standard form. Our a value is 25. That means it opens up. Our c value is 9, which means on the y-axis it crosses over at 9. All right, well, let's see what else happens. Taking the liberty of bringing in a picture to show you what's going on here. So if we just enlarge it a little bit, we have the scale change. So here's 1. Choose a better color. Here's 1, and right here is -1. And then on our y scale right here, that's 9. So this thing is opening up, y-intercept of 9, and it only hits the x-axis one time at the, yes, you guessed it, vertex. So our vertex here must be at 3/5, 0. Keeping in mind that when we're in standard form, the vertex is at the opposite of b, all over 2a, comma some y value. And if you think about it, in the quadratic formula, this is the opposite of b. This is 2a. And when this is 0, you got your opposite of b all over 2a. Hey, interesting how this all ties together. Next. Our next example, of course, first things first. Let's get this into standard form. So subtract 5 from both sides. And we get -x squared plus 4x minus 5 equals 0. A equals -1, B equals 4, C equals -5. For time's sake, I'm just going to get right into it. X is equal to opposite of B, -4, plus or minus square root 4 squared minus 4 times -1 times 5 all over 2 times -1. Press pause. Take a minute to do the math yourself. Okay, and you should have gotten to this point at least. And there's some good stuff that's in this one. Good practice here. First, we're going to simplify that radical. So it's -4 plus or minus. Now again, that -4 is like a -1 times 4. So that's plus or minus 2i all over -2. Now, all three terms are divisible by 2. So we're going to go up to the upper right here and say that's x equals -2 plus or minus I all over -1, or that's going to be x equals 2 plus or minus I as a final answer, because negative divided by a negative is a positive, and plus or minus divided by a negative is plus or minus still. So here's our final answer. Alright, now what does this tell us? This tells us that we don't cross over the x-axis. Alright, let's take a look at the graph of this standard form parabola here. And lo and behold, it opens down and never touches the x-axis. See, it opens down with a negative y-intercept. So there's your -5 opening down. And you might ask yourself, well, Mr. Brecklin, what if we had moved all of this over to the other side? You said you like to keep the coefficient positive. Well, then that would have been a sort of, not the exact reverse. I'm sort of going to cheat here for a second, but really this parabola would have been over on the right side again. And perhaps, let me try again. If you grab your graphing calculator and you pop it in the y equals this as you see it, and then also the opposite would have been positive x squared minus 4x plus 5 equals 0. That would have been this version here. So either way, it either opens up with a positive 5 y-intercept not touching the x-axis, or it opens down with a negative. So you'll get the same x-intercept or imaginary intercepts values. What you want to do on this screen right away is press pause, copy all of the information that's in the white boxes, and then we'll go through this. All right? So, the key piece of this is to focus on the red writing here, this b squared minus 4ac. That's what we refer to as the discriminant. You'll need to know that word. The discriminant tells us something interesting about the number of solutions or x-intercepts that we really have. In our first example in this video, you weren't really paying attention to it, but we had the square root of 17. 17 is our discriminant. Since 17, right, that's the value of b squared minus 4ac, is larger than 0, we had two intercepts. Go back and look at your notes. It crossed over the x-axis twice. It wasn't pretty. It didn't cross over at integer values, but we did have two real solutions. Okay, they weren't rational solutions. They weren't integer solutions, but they were real. Next, our next example, we had a square root of 0, and we ended up with, square root of 0 is just 0. And I did slip in that, that's only one value, so we only have one intercept, or one real solution. Again, 0 being equal to 0. That b squared minus 4ac, the discriminant, was equal to 0 in that example. So we had one real solution. Okay. On the last example, we had a discriminant of negative 4. Okay, you can't take the square root of a negative number, or I should say you can't take the square root of a negative number and get anything other than imaginary solutions. See? Imaginary solutions. So that's when we know that it's either opening up and above the x-axis or opening down and below the x-axis. And it could be over here or over here. It doesn't necessarily have to be in the one location that they're showing it. So there you go. If the discriminant is less than 0, i.e. a negative answer, you're going to have two imaginary solutions. Equal to 0, one real solution. Greater than 0, two real solutions. Okay? Your mission is to tackle the red problems here, right? We're going to solve these using the quadratic formula, okay, using the QF. And then on the orange ones down here at the bottom, all I want you to do for these is to find the discriminant and then tell me the number of solutions that's associated with each one of them. Okay, so don't forget, the key to this is first to put them in standard form, identify A, B, and C. Good luck, see you next class.